Thank you everyone for joining us today on the Cloud Native Islamabad webinar. And today we are talking about Kubernetes Event-Driven Autoscaling with my guests from the Keda maintainer team, Tom Kerkhove and George Turrado. Thank you very much for joining me, Tom and George. Let's introduce yourself to our audience first.
So, hello everybody. My name is Tom Kerkhove and I'm a software engineer at Microsoft and I'm one of the Keda maintainers.
Hi to all. I'm Jorge Turrado. I'm SVP at DocplannerTech and I am another one of Keda maintainers.
Yes, absolutely. Thank you very much, first of all, for joining me and tell us about your first few experience of how long been, and also the new release that is Keda is coming up. I've seen that and looking forward to doing a hands-on experience. So tell us about what we're going to be experiencing and what we're covering today.
So today we'll do a brief overview of how application autoscaling works on Kubernetes without Keda, and then we'll show you what Keda is, how it simplifies things. Jorge will do a demo, and then we'll also talk about our community and what's coming in the future.
Yes, absolutely. I'm looking forward to that. So feel free to share your questions on the chat. We will monitor those and we'll ask those as we go live and at the end as well. So thank you very much for joining everyone. So I'm going behind the scene and now it's time to share and
Okay, so let's dive right into it. So if we have a look at vanilla Kubernetes with nothing installed, etc., and imagine we have multiple applications running. These applications use external sources, or it can even be inside the cluster. Like if you run Prometheus or Kafka in your cluster, you would like to scale based on notions of information for them, or based on the cloud provider that you have. So if you want to achieve this in Kubernetes, what you have to do is you have to use what's called a horizontal pod autoscaler, which allows you to, hence the name, scale your application horizontally. But of course, it needs to have that information. So in order to achieve that, you need to use what's called Kubernetes external metrics. So out of the box, the horizontal pod autoscaler allows you to very easily scale CPU and memory based. But in this case, that's not an option. So you have to use external metrics because the systems are not in the cluster. Now, in order to achieve that, you need to install what's called a metrics adapter or a metrics server, which is able to get the metrics from that system and make them available to Kubernetes. So in theory, you could use this, but there's one caveat though. You can only run one of these metric adapters in one cluster. So what you would have to do then is pick one of them and bring all the metrics into that single place. It is also possible, but it's a bit clunky, and you also have to run all of this infrastructure yourself.
Maybe
why not make this simpler?
Maybe a good example of this is, for example, if you are working with Prometheus, it's very common having Prometheus adapter. But when you discover, or when you started with working, for example, with Rabbit, you will discover that both adapters, Prometheus adapter, but also Rabbit adapter, use the same endpoint, and they cannot live together. And as Tom said, you probably need to dig in and scrap the metrics from Rabbit into Prometheus in order to use the metrics from there for scaling. And it's more complicated infrastructure than the option that we are going to present.
Yeah, so in the end, what I typically call your auto-scaling infrastructure will only grow and grow because you'll be installing all of these Prometheus exporters in this scenario or other workloads just to get that information. So that's where Keda comes in. Keda really strives to make application auto-scaling that simple so that you can focus on scaling your application and not how the whole scaling internals of Kubernetes work. So what does Keda do? Keda allows you to auto-scale deployments, jobs, or practically any Kubernetes sub-resource that has this /scale sub-resource. So you can also scale your own custom workloads if you want to. And you simply do it by using one or more of the scalers that we have in the catalog. So today we have more than 40 of them. But you can also build your own external scaler, external push, or feed it with the metrics that we can scale on. Of course, we are also open to contribution. So if you have an idea of a scaler that's reusable for a third party, for example, or a product out there, we are always happy to have pull requests or feature requests for them. Now, another benefit is that we also allow you to scale all the way down to 0 so that you can really optimize your costs. And we also provide some capabilities for authentication, which allows you to have production-grade security. And we are happy to be a CNCF incubation project as of last year. So that really helps us be part of the cloud native community. So if you go back to this view and we have a look at how it works with Keda, is instead of using an HPA, you first install Keda, which will bring all the scalers. And Keda knows how to talk to all these various external systems. And second is you install what's called the scaled object. The scaled object defines, I want to scale this workload, and I want to use these scalers. So what happens then is Keda's scale controller will basically use the scalers to keep track of the external systems, and then it will feed all the metrics to the HPA. Now, if you scale from 1 to 0 or 0 to 1, Keda will also automatically create or remove the HPA for you. And because we want to build that unified application autoscaling layer, we also allow you to scale CPU and memory-based through triggers, so you don't have to mix and match HPAs with Keda. So you can fully rely on Keda to achieve all of this. So how does it work under the hood? So Keda is not reinventing the wheel, but basically extending Kubernetes. So we have our own metrics adapter, and we feed all our metrics into the adapter so that Kubernetes can scale on them. And like I mentioned earlier, we rely on the horizontal pod autoscaler for this, and we remove and create it on the fly for you. And it's very easy to install. You can use Helm chart, you can use our YAML spec, or you can also use Operator Hub, basically whatever is useful to you. Now, I mentioned authentication and production-grade security already before. Now, while you can add authentication from the workload itself, we really allow you to separate the concerns between the workload and the autoscaling, but also between the application team and the operating team if you have to. And that's why we allow you to create what's called a trigger authentication or cluster trigger authentication, which allows you to define the authentication once and reuse it on your scaled object or scaled job through a reference. So team A can create the scale object, team B can manage the trigger authentication so that they are fully decoupled. Another interesting point is your authentication is decoupled from the workload, so you can use environment variables, Kubernetes secrets, no secret authentication for Azure and AWS, and also pull secrets from HashiCorp Vault. If you want more secret providers, we can also add them, of course. So feel free to open feature requests. I know we have Spiffy on the backlog, for example. So if you want those, just give a thumbs up or even maybe contribute them. That would be very nice. And this is a list of our current scaler catalog. Some of them are through external scalers, but the majority of them are baked in. But this list is always growing. So again, we'd love to hear what you would like to see as well. Now, talk is cheap, so I will leave it up to Jorge to do a demo so you can really see how simple it is to use Keda.
Yes, I did my homework. So let me share the screen. This one. Okay. I'm sorry. Oh, okay. I'm gonna show a demo that could be the super common use case in any event-driven infrastructure. Basically, we have one worker which, in this case, read messages from a service bus queue, but it could be Rabbit or it could be Kafka, the queue service that you prefer. And we have a website which we could use, for example, to monitor the queue states. And also we have our workload generator that could be, imagine, for example, when a user register in your website and event is rising from the domain, and this queue stores the event in order to recovering them from the worker. This basically for simulating some load, the worker will pull the image, pull the message, sleep 2 seconds just to simulate some hard work in the worker side, and then go to the next message in the queue. This sample, first of all, this sample is in our repositories, so you could pull it and try by yourself. And of course, any feedback is welcome if you have anything or you discover any bug. First of all, for this demo, we should decide if we want to use Azure Pod Identity or connection string. Let's go in the easiest way with the connection string. The idea, let's see in the code because it could be easier. Basically, we will deploy one deployment which deploy the queue with one secret with the queue. I have already deployed that in the infrastructure, and it's scaled to 0 because obviously we don't have any message to process. So we scaled it to 0, saving money. If I don't need to process any message, doesn't make sense having resources there, paying from resources that we are not using. And this is a good point from Keda. First of all, the Keda related part, because this part is totally related with the application. All of your applications could be like this. It's not rocket science. The interesting part from Keda is this section, is the scale object related things. For example, as we saw, as Tom said during the presentation, we have a system to create secure triggers, to secure the triggers, to pass in the secrets to the triggers, and we have our scale object. This is the object that Tom saw during his presentation that we use to say say to Keda, okay, you should monitor this. In this case, you should monitor this deployment, and you should scale in base of the trigger. Basically, we are gonna scale from 0 to 50 using a service bus queue. Okay, and we have the message created, the message generator. I will run it, for example, and let's say that I want to enqueue 400 messages. I can see on the website that the messages are growing, but also I could go to the cluster, and the first thing that I will see is that Keda will scale from 0 to 1. And as Tom said, Keda does this part for that related with scaling from 0 and to 0. And once is the application started and has at least one instance, will the HPA controller who manages by itself the autoscaling. So Keda extends the HPA controller, but don't avoid the use of HPA controller, because HPA controller is a very important piece in Kubernetes, and it works really fine. Doesn't make sense. Reinvent the wheel just to avoid using already existing software. Now the queue is being processed, and during the time we will see that the pending messages are decreasing over the time. Of course, Keda will continue exposing the metrics, and if the HPA controller thinks that it's necessary scaling out more, obviously the workload will be auto-scaling as based on CPU or memory. Have you got anything to add to this demo, Tom?
No, not from my side.
Okay, just to avoid the silence. But after this workload finish and we don't have any pending messages, we will check in the cluster that after a few seconds, the workload will be scaled to 0 again.
Yeah, obviously we're biased, but it's nice to see how easy it is to just apply a scaled object on an existing workload without making any changes.
Yeah, for sure. We don't need to change anything in our deployment. The only thing that we need to add is a new scale object in the same way that we could use, for example, for HPA.
Yeah.
One important point here is that under this behind the scene, Keda will create the HPA. So don't create another HPA from yourself. In the same way that you don't have two HPA for the same deployment, you cannot create one HPA and one scale object for the same deployment from the same monitored workload, because in that case, the HPA controller will try to scale out and scale in randomly, depending on which HPA is managing in that time. After some time, as I said, we don't have any instance because we don't have any workload, any message to process. We don't have any pending message, so we have 0 instances. We scale it to 0, saving money, for example, during night or during the night, or in general when we don't have any pending work.
Okay. Thank you for the demo.
You are welcome.
So going back to the slides, I will briefly show one example, which is for Azure, where Keda is being used as part of the offering to scale things. So as of a couple of years, you can run Azure functions outside of Azure. You can also nowadays run logic apps outside of Azure, but they still need that serverless capability, that serverless scaling. And that's why they actually use Keda for that. And if we have a closer look, if you are using Keda, most probably you've used the core tools before. And as part of the core tools, actually, you can very easily deploy your Azure functions to Kubernetes without even knowing what Keda is, how Kubernetes works, etc. If you want to give this a try, it's just 3 commands away. So first you create a new Azure function with a service bus queue trigger. Then you just initialize it so that it adds a Docker compose file to it. And if you then do a func Kubernetes deploy, it will actually build your whole Azure function to a container image. It will push it to a registry. It will generate the whole YAML specification, not only to deploy the application, but it will also add the scaled object with the trigger, etc. for you and deploy that to the cluster. If Keda is not installed, it will even install Keda as well. So this is one example of not only end users using Keda, but also other people using Keda as part of their offering. And in this case, they even make it a lot simpler, even to deploy and scale a Azure function on Kubernetes. So this is a nice segue to the community and who's actually using Keda, because that's also important. Why should you use Keda? First, let's have a look at the history of Keda. So in May 2019, Keda was announced as a partnership between Microsoft and Red Hat. And then in November, we shipped Keda v 1.0. And actually, that's a nice momentum for me personally, because that was the last in-person conference that I did. before all of this happened, unfortunately. So in March, then we decided to donate Keda to CNCF in 2020, and then in November we shipped Keda 2.0. HTTP add-on was something that we announced in June. So that's an external scaler that we built next to Keda to do HTTP-based autoscaling. The reason why this is an external scaler is HTTP is not trivial to scale. Certainly 0 to 1 or 1 to 0, because if a request comes in, you have to capture that request until the workload has spun up. So that's why we built an add-on for that. And then in August last year, we actually graduated to the CNCF incubation last year. So it's been a nice journey, but we also see that through the adoption. So actually, I checked today. So we have 34 million pulls on GitHub Container Registry, and that doesn't even include our Docker Hub pulls, which was our initial registry. We have more than 4,000 stars on GitHub and 170 contributors. And we have 26 listed end users who were happy to be part of our community. If you are using Keda and want to become one, just let us know, because it's just one pull request away. And we also had the honor to have Alibaba Cloud and Cast AI do a reference case on our blog, and we also have Zapier coming up, who is also happy to use Keda. You can actually already read about Zapier on the CNCF blog as well, if you can't wait. And over time, we've been constantly adding more and more scalers, so we're already above 40 even. So if you have ideas, just let us know. But this also proves that, yeah, we keep on adding them, because this is really the power of Keda itself. So this is really important for us as well. We want to help you really make it super simple. And then just to put some names on who's using them, these are all the ones that we know today that is using Keda, including DocPlanner itself as well. So it's constantly growing, and we're happy to have them. And if you're interested, you can also join our bi-weekly community stand-ups, which you can find on the link as well. If you want to read about Alibaba Cloud, it's also on the CNCF blog. So if you go to bit.ly/Alibaba Cloud Keda, you will also be able to read about that. You can also find the external scalers of Keda on Artifact Hub. So there is actually a Keda scaler kind. So our official external scalers are there. Of course, our community also has them. So if you've built one, you can easily add them to Artifact Hub so that people can more easily find them. We will also integrate this in our documentation eventually, so that we also help with the discoverability of these external scalers. So what are we going to work on in the future, or what are our ideas? Like I mentioned, we constantly add more scalers and secret sources, so let us know if you want to have others. I already briefly mentioned our HTTP-based autoscaling, which is in beta. Obviously, we'll continue working on that, because today I think we only support ingress, but we want to support ingress, service mesh, service to service, whatever people need. And we will also add cloud events in the future, so that we will have the capability so that people can subscribe to these events and they can extend their workload. So for example, you could subscribe to the events and then automatically post a message in Teams so that you have that scaling awareness, for example. For historic analysis and predictive scaling, we're considering to open up the metrics that you have so that you can store them and run AI models on top of them. We don't have this in Keda core today, but we have added a new scaler though, which is the predict cube one. And predict cube is an interesting scenario because predict cube is an external service, a third-party service, which is available for everyone. You just create an API key, you need Prometheus, and then people can just integrate with the service, and they will proactively scale your application so that for example, if on a daily basis you have message spikes on your queue and there is a pattern, why wait until all the messages are there while you can proactively just scale out already. And then there's two issues that we have upstream is you cannot run Keda highly available, and you cannot run multiple instances of Keda in one cluster. So eventually we want to see how we can improve that as part of Keda or improve Kubernetes to support this. And sorry to interrupt, Jorge. I think you
No, don't worry. The thing that I wanted to say that, for example, another use case interesting for PredictCube is imagine that you are running heavy nodes and you need to scale. All this predict scaling will help with heavy startup applications, because if you need 1 second to start up, go ahead and scale without any predictive method. But for heavy load, it's a super interesting addition that we recently achieved.
Yes, agreed. And then just an example for HTTP-based autoscaling. So there's no dependency on anything. You don't need to bring your own Prometheus instance, which is often required for other tools and autoscalers. We don't want to force this on you. So if you have Prometheus, actually you can already scale based on your ingress metrics. Just do know that if you scale to 0, you need to have something intercepting the traffic, but that's up to you. This is what an HTTP scaled object looks like. Similar to a scaled object, you have a scale target ref with the name of your deployment, in this case, the service and the port. And then you define the amount of replicas that you want. Because in this case, there's an interceptor between your client and your API or HTTP workload to handle that 0 to 1 and 1 to 0 scaling. So here's an overview from the documentation where in green is the Keda pieces, and then in blue is what you actually do as a application user. And actually this deployment here, that should be in blue because that's your own workload. All the rest is the HTTP add-on, which basically intercepts the traffic and make sure that the external scaler can scale if there's a need, and then it just forwards the traffic to your deployment. But of course, you don't just turn on application autoscaling without scaling the cluster, because then you'll have an interesting day. Let's put it like that. It's nice to scale your application, but Kubernetes is more than applications. You have to take care of the cluster as well. And that's why I typically call this the autoscaling sweet spot, where you will have Keda to scale your applications. And then at some point, your nodes will be full. So then that's why you should have cluster autoscaler, for example, to balance the nodes and react to that. But eventually, you'll hit capacity issues again. Cluster autoscaler will not be fast enough. If you're an Azure customer, you can also use virtual nodes in Azure so that the capacity overflows to Azure container instances. And then eventually, if things scale down, you can actually optimize your cost again by combining these three technologies. So you really build a cost-efficient ecosystem for your Kubernetes applications. And with that, I'm at the end of my presentation because we wanted to have some room for questions. So let me check. So Jan Halen says, can you show which controllers Keda is running to do this? to recreate the correct HPA object. So CAADA has an operator and has a metric adapter, and those are the two workloads that it runs. I'm not sure if that's...
that I sent a link, but probably YouTube blocked it.
Sorry?
I think that I already answered that question, but probably YouTube blocked my message because it contained a link. So
okay,
YouTube thinks, okay, this is a spammer. Let's block it.
Don't take it personally.
But I will share the screen for a moment.
Yes, yeah, only one operator indeed. So there's the operator and there's the metric server. Okay, I don't see any other questions.
Thanks, George and Tom, for the wonderful demo. I think it's the demo actually shows you how easy it is to scale your workloads with using. I think that's really get the power out. And also tell us about the more things like when do you think like people are already using the HPA, the horizontal pod autoscaler that is starting? Do you see, you have this condition, when do we able to move from HPA to Keda or Kubernetes Event-Driven Autoscaling? So is there some kind of best practices or the scenarios when you move to, or people are already using HPA? What are the resources, what are the things you want to go through them and they want to get started with Keda in easily and efficiently?
Well, if you use an HPA, that most probably means you just use CPU and memory. And if that's the case, then I always say, yeah, why not go straight to Keda? Well, because maybe in the future you'll need this other scaler that we already have, and then the impact is almost nothing. If you want to migrate, correct me if I'm wrong, Jorge, but actually it's fairly simple because you can just use the triggers, but we also allow you to configure the HPA underneath if you know what you're doing through the advanced section. So you can also still do that. So it's not that we create a black box on top of it. You can still manage it, but we try to avoid it because we want to make it simpler for you.
In fact, we understand that some users has their own use cases. For example, I remember one top one issue in the repository with a super specific scaling case. They needed to be super aggressive scaling out, but also scaling in. The HPA as default is super carefully with or scale in super carefully, and they need to modify. And for example, as Tom said, the scale object allows you to specify the advanced section directly from the HPA, and Keda will create the HPA passing your configuration, so the HPA controller will take into account your requirement. So I think that it's super easy. The migration from one to another, it's super easy. Probably you only need to refactor a bit, rename, and maybe we are working with YAML, change any indentation. But apart from that, it will be super easy. There is another super interesting feature that we didn't say anything about it, and it's the fallback way, because we said that we cannot work in high availability because the upstream, not we, all the metric servers cannot work in high availability because the upstream limitation. But what happens if Keda works, but the upstream not? Maybe because your Prometheus server is down, AWS is offline, Azure. Keda supports a fallback method, a fallback configuration. So if you face it with problem, imagine that your Prometheus server went down, Keda allows you to specify, okay, if the upstream doesn't respond 3 times in a row, go to this amount of instances, go to 10 instances. Go to the safest amount of instances just to don't impact. Probably you spend more money, or you could spend more money because you are not auto-scaling in base of the upstream metric, but at least you will not face with performance problems related with having 2 instances when you need 10. So it's a super interesting configure, a super interesting option from my point of view. In in my current company, we use it, and because maybe the node is down, maybe connectivity issues, maybe shit happens. So it's a very interesting feature.
Yes, absolutely, absolutely. And I think the most like the list of the project and the list of the adopter who are using the Keda is growing every day. Like people are using, and I see a lot of the blog posts are talking about how they are using and how they've solved some of the problem they had by using Keda. And also one of the project that I think from the Azure team, because I'm working a lot on the Azure side, and the Azure Container App, I'm seeing under the hood they are using some Keda functionality. So Tom, so can you point us about the people who are using Azure Cloud, where they see the Keda fit into the Azure Cloud? What are the projects are using under the hood, the Keda project?
So I think if you use Azure Video Indexer, they use Keda to scale their internal system. But also, like I mentioned, Azure Function Core. So Azure Functions uses it if you deploy it to Kubernetes. Then you also have what's called Azure Application Services for Azure Arc. So that brings the whole PaaS stack outside of Azure in a managed offering, and they don't surface this to you because you don't have to care about it. But when you deploy a web app to Arc, it's actually going to scale that web app through Keda as well. So they install the control plane and include Keda. And then the new Azure Container Apps, which is containers as a service in Azure as a PaaS service, is actually built on top of Dapper and Keda, where they have this as part of their managed offering as well, which are the ones on top of my mind.
Yes, absolutely. I think that's a great list. Then that depicts that you have to learn Keda functionality under that. And also, before I let you go, the final thoughts like Keda is working or just in the other clouds, like on the Amazon or the GKE. Is it fit all the other cloud use cases as well?
So we support AWS, Azure, GCP, Alibaba Cloud, and Huawei Cloud, which is apparently also a cloud, as scalers. But then I just mentioned Azure, but also Alibaba Cloud has an application offering. I forgot the name. I think it's Alibaba Cloud Application Service that also uses Keda as part of their offering as well. So we have them both as a trigger and also as an end user where we can help them. So any major cloud we support.
Yes, absolutely, absolutely. So thanks very much, Tom and George. It's been a wonderful talking to you today on learning about the Keda. Hope to catch up you again in the future as well, learning about more things going up. And it's been the CNCF incubated projects. You can see the talks available on, I think, the CNCF channel as well. And I will post the resources for you in the on the Twitter side as well of people who are who want to learn more about Keda. So Tom, George, it's been a wonderful talking to you today. And I hope you catch up you again in the future as well. Thanks for sharing your time with us today or learning about the Keda. Thanks, everyone. Please join us again in the next webinar. Stay safe, stay healthy. Bye-bye, everyone.